Hi everybody, Mr. Eicher here. We have some power outages, so here's a video for what we're going to do in class today. We're going to do this question from the 2015 AP Stats exam. It's a probability question based on the past 2 chapters worth of probability stuff that we've done. On the AP exam, you can expect to have at least one free response question that's all about probability, if not maybe 2 questions. So I'd encourage you, what I intended on doing in class, I'd encourage you to pause this video and give yourself 10 or 15 minutes to attempt this question. And then when you're ready, you can press play and we'll go through the solution as well as the scoring for this question. Good luck. All right, welcome back. Let's go through the solution and the scoring. In part A, we're asked the probability at least one ATM is working. So that's the probability that our random variable x, by the way, x is called a discrete random variable. It's discrete because there are gaps between 0, 1, 1, 2, and 2 and 3. You can't have a half an ATM working. It's either working or it's not working. It's not continuous. It's not an interval of values that it can take, but these are particular discrete values with gaps in between. So it's a discrete random variable. On this question, we want at least one. At least one would be greater than or equal to 1. And that would be the probability that 1 is working, or that 2 is working, or that 3 is working. And this would be 0.85. You could also find this by using the complement, 1 minus the probability that none are working, which is also 0.85. To get full credit on the AP exam, you would need the work plus the answer. So that would be an E, a full credit, essentially correct. Otherwise, it would be a partial. In this case, they awarded a partial. If you only had this, then that would be a partial credit on this. You could also have this work with the complement. That's fine. So if you got that one so far, you would be 1 out of 4 points on this FRQ. Next, the question is, what is the expected value of the number of ATMs that are working? The expected value is the same as the average or the mean number of ATMs that are working. And to calculate that, there's a formula on the formula sheet. You take the outcome times the probability of that outcome, and then you sum those up. So in this context, we'd have 0 times 0.15 plus 1 times 0.21 plus 2 times 0.40 plus 3 times 0.24. And adding those up, we get 1.73 ATMs that would be working when the mall opens. To be able to get full credit, again, you would need to show work for your calculations and get the correct 1.73. So if you had that, that would be scored an E. So out of the first 2, if you got both of those full credit, then you would be at 2 out of 4 points. If you can average 2 out of 4 points on the AP exam, that would be getting about 50% of the free response. Obviously, depending how you did on the multiple choice, if you got about 50% on the multiple choice, you would be scoring a middle to high 3 on the AP exam. Next question, C, what is the probability that all 3 ATMs are working when the mall opens, given that at least one ATM is working? This given indicates that this is a conditional probability. So as a conditional probability, we're being asked, what's the probability that 3 are working, x equals 3, given that at least 1 is working? So the condition here, this is going to be our denominator. And then our numerator is going to be, I'll show you what the notation looks like. Our numerator is going to be, we have our denominator. Our numerator is going to be the probability that x equals 3 and the probability that x is greater than or equal to 1. Now, if it is 3, then automatically it's greater than or equal to 1. So really the numerator we just want is the probability that it is 3, which is 0.24, and the denominator is 0.85, what we calculated in part A actually. And then calculating this, we get approximately 0.28. So to get full credit, to get an E on this part, you would need at least the fraction of how you got 0.28, and then the answer is 0.28. If you were looking for partial credit was awarded if you got either the top or the bottom. You have a fraction shown, but you only got one of the two. One of two correct, but not both. That would be a partial. And there weren't many other ways to get a partial on this question. You had to recognize that you needed a fraction as a conditional probability. So if you didn't recognize that you needed a conditional probability, you'd probably get an incomplete. So let's hope and imagine that you got an E on this. That would be fantastic. At this point, if you got A, B, and C, you'd be at 3 out of 4 points. 3 out of 4 points is the really golden number. It's difficult on the AP exam to get 4 out of 4s on questions, but if you can get 3 out of 4 on a question, on multiple questions on the free response, then you're fixing yourself up for a 5 on the exam, and that'd be fantastic. Five-tastic? Fantastic. The last question was the question that was most difficult for students, and that's pretty common on questions just in general on the AP exam. Usually later parts are more challenging. It says, given at least one is working, that sounds kind of like part C that we just answered, would the expected value of the number of ATMs working be less than, equal to, or greater than the expected value from B? Now, it was really common for students to look at their calculation in part B. The answer we got in part B was 1.73. And it was common for students to say, well, if I got rid of this term, then it looks like this calculation right here is going to be the exact same number, 1.73. So it was pretty common for students to guess equal to and then make their argument. But actually the answer is not equal to. The answer is greater than. So let me explain why. First, we'll say the expected value would be greater than 1.73 if we remove 0 ATM option. Why is that? Here's 2 different ways that you can think about it. One way to think about it is if we remove this, like say this never existed here. If we remove that, our probability distribution left over, this right here, these probabilities should add to 1. They should sum up to 1, but they don't. So what we're going to have to do is we're going to have to reweight these and think of, well, if this 15% that had been there is kind of left over that we can kind of evenly distribute, maybe not evenly, but we can distribute among these other probabilities, all those probabilities are going to increase. So if all those probabilities increase, the expected value is going to increase. So that's one approach that you could take to argue if we remove 0 option. So we would say remove the 0 option since each probability of 1, 2, 3 ATM will increase, making the expected value higher than 1.73. Another approach you could take is you could actually calculate, you might be interested in this, you could actually calculate the new expected value. So if we did that, we would have, remember we had the at least one probability of 0.85. And those probabilities that we had originally, 21, 40, and 24, we could say the 21, 40, and 24, let me write these out. They need to add to 1, so what we do is we'd weight them each. Instead of out of 1, now they're out of 0.85. So if we calculated those probabilities, we would get 25, 47, and 28. Now if you add those add up to 100%, so the probability distribution is valid now. And now we can recalculate our new expected value to be 2.04 ATMs. So I hope it makes sense. Like, if you're expecting 1.73 ATMs to be working, if you remove the possibility that one of them, that like they're all okay, that zero are working, then the expected number of ATMs is going to be greater than before. So if you're saying like at least one is working now, then you'd expect that the overall how many are working is going to be higher. And with this calculation, you have 2.04 ATMs are working, which is greater than the 1.73. So to get an E on this, first you have to say greater than. If you didn't say greater than, then you can't even get partial credit. So then to get an E, you could either make an argument like we did here, but you have to say that each probability is increasing, or something about proportionally they're getting bigger because we threw out the zero case. Or if you did this kind of approach, this is a really good approach because you've actually calculated it. So if you said greater than, but your explanation wasn't the strongest, then it would be a partial. If you did one of these approaches, that would be an E. If you said one of the other options, less than or equal to, then that would be an I, and no credit was awarded for that. So if you actually got this question, then you got 4 out of 4 if you got A, B, C, and D. Let's say, just for instance, maybe you got an E on the first two, maybe an E on the third, and then a partial on this one. That would be a 3.5 score. And half scores aren't awarded on the AP exam, so your whole response would be reread, and it would be determined if we should round it up to a 4 or round it down to a 3. And I can talk more about that later, but that's called holistic grading. We look at the whole response, the whole thing, and determine, is there anything you did really well that we didn't award you for, or is there something that you didn't do very well and you didn't lose points for, but you still got an essentially correct, but it was like a weak essentially correct. That might be another reason why it would be rounded down to a 3 rather than up to a 4. I hope this video is helpful, and I hope to see you in class next time. Bye.